In this lecture, we take one more example on Maclaurin's theorem to expand the tangent function. Let f of x be a function of x differentiable n times, then Maclaurin's series of f of x is given by f of x is equal to f of 0, f of x equal to f of 0 plus x f dash of 0 plus x square upon 2 factorial f double dash of 0 plus x to the power 3 upon 3 factorial f triple dash of 0 and so on. Here f of x is equal to 10x. Let us consider this 10x is equal to y. And if you want to find out the first term f of 0, let us just put f of 0, 10, 0, and 10, 0 is nothing but 0. Now we want to find the derivative of 10x. Derivative of 10x is nothing but sec square x, and we know that sec square x can be written as 1 plus 10 square x, and we again know that from the previous equation 10x is nothing but y, so we can write down 1 plus 10 square x can be written as 1 plus y square. And if we put the value of x is 0, f dash of 0 is y1 0, which is equal to 1. This term is 1, and y0 whole square, and y0 is nothing but it is again 0. So we can write down this value is 1. So f dash of 0 is 1. Let us find out the second derivative, f double dash of x. F double dash of x means y2, and y2 is nothing but the derivative of 1 is 0, and derivative of y square is 2y y1. Right? Derivative of y square is 2y, and since y is function of x, so again derivative of y is dy dx, and dy dx is nothing but it is y1. Now, if we substitute the value f double dash of 0, we want to find out the value of f double dash of x at x equal to 0. So let us put just what is the value of x is in the given expression. We are getting y to 0, which is 2. Y of 0 is nothing but we have already obtained. This is 0. And y1 of 0, y1 of 0 is 1. So 0, y0 is 0, y1 is 1. So ultimately the answer is 0. So f double dash of 0 is 0. Let us again differentiate with respect to x. Y3, which is equal to, now there is a product of two functions y and y1. So if we find the derivative of this, we use the product rule. First function y, derivative of y1 is y2 plus derivative of first function y. What is the derivative of y? It is nothing but y1 and into y1. So y1 into y1, it will become y1 square. Okay, so now here, if we substitute the value of x as 0, we are able to get the value of y3 0. And we know that what is y0? Y0 is 0. Y2 0 is also 0. Just look here. Y0 is 0. Y1 0 is 1. And Y2 0 is 0. So Y1, Y2 0 both are 0. But Y1 square, what is the value of Y1? Y1 is 1. So here we are getting 1 square is 1. 1 square is 1. So 1 into 0 plus 1 is 1. We have to multiply this by 2. 2 into 1 is equal to 2. So f triple dash of 0, or we can say that y3 of 0, its value is 2. Let us go ahead to find out again one more term. We will try to find out. Then it will very clear. Y3 f triple dash of x, which is y3, its value is, we have already calculated it, its value is 2. Now again differentiate fourth time. So f fourth derivative of x is y4. Now here we have to use the product rule over here. First function y, derivative of y2 is y3 plus derivative of this y is y1 into second function y2 plus derivative of y1 square is 2y1, and again derivative of y1 is y2. Let me again explain this once more. This is the product we want to find out the derivative of y into y2. We use the product rule. So product rule says that first function derivative of second function. So first function is y, derivative of y2 is y3 plus derivative of first function. So derivative of y is y1 into second function y2 plus what is the derivative of y1 square? So derivative of y1 square is 2y1 and again derivative of y1 is y2. And if we substitute the values, what will happen? Just look here. We know that y0 is 0, y20 is 0, and y20 is 0. So all three terms will become 0 because these are multiplied. So ultimately we are getting y40 is 0. I think we should also try to find out what is y5 x. So let me write down over here. First, we have to write down what is the derivative of y3. So first function y, derivative of y3 is y4 plus derivative of y is y1 into y3. So this is what the first two terms are derivative of first term, this one. Now, what is the derivative of y1, y2? So y1 derivative of y2 is y3 plus derivative of y1 is y2 and again y2, so y2 square. This is the derivative of this part. Similarly, if you find out the derivative of y1, y2, so 2 times of y1, derivative of y2 is y3 plus 2 times of derivative of y1 is y2, y2 into y2 is y2 square. So I think this is clear to everyone. We have three term and we are using the product rule. So this three term will convert it to 1, 2, 3, 4, 5, 6 term. Let us just simplify and we will try to write down the common terms in one place. They're like that y1, y3, y1, y3. So it will become 2 y1, y3, y2 square, 2y2 square will become 3y2 square and then y1, 2y1, y3. If we substitute the limit, what will happen? Just look here. Y4 is 0, so it will become 0. Y1 is 1 and y3 is 2. So 1 into 2, 1 into 2 is 2, 2 into 2 is 4, right? Again, okay, y1 and y3, again 1 into 1. So this is 1 into 2, so again 2. The 2 plus 2 is 4 and 4 into 2 is 8. Okay, now again there is y1, y3. Okay, so this is 4 times of y1, y3. So 4 times of 4 into this 1, 2, 3, 4. So 4 into 2 is 8 and 8 into 2 is 16. Right? This will become 0. So ultimately we are getting the y5 of 0 which is equal to 16. Now in this manner we are able to get the higher derivative, but this is more sufficient to find out the general series of tanx. So putting above values in the equation number 1, we have f of x which is nothing but tanx. Then f dash of 0 is 0, x f double dash of 1 is 1, f double dash of 0 is 1, x square upon 2 factorial f double dash of 0 is 0, x cube upon 3 factorial f triple dash means y30 is 2, x to the power 4 upon 4 factorial into y40 is 0, x to the power 5 upon 5 factorial into y50 is 16. So if we put all these values, we are able to write down the expansion of 10x, which is nothing but x plus x cube upon 3 plus 2x to the power 5 upon 15 and so on. So now if we write down up to the power of x, then this is also more than sufficient to write down the expansion of any function. So in this manner, we are able to get the expansion of 10x. And what is the expansion of 10x? It is nothing but x plus x cube upon 3 plus 2 upon 15 into x to the power 5 and so on. Thank you.